Our next presentation will be on PRC-5-6, and we will welcome Craig Struck and Jessica Molina to begin that presentation.
Good morning, everyone. My name's Craig Struck, and my fellow co-presenter today is Jessica Molina. Jessica and I are both auditors in the WECC Entity Monitoring Group, and we're part of the team that performs the compliance monitoring methods that Stacia just spoke to. We're here today to talk about the PRC-5-6 reliability standard. This standard addresses the maintenance of protection systems, automatic reclosing, and sudden pressure relays. Next. In this session, we'll cover the history and future of PRC-5, some of the key aspects of identifying applicable protection systems, elements of automatic reclosing and sudden pressure relaying, and their associated protection system components. After those higher level topics, we'll move into the individual requirements and the main concepts of each requirement. Keep in mind there are three main concepts in PRC-5-6, and these are: one, a program that defines how you'll maintain protection systems. Two is the intervals in which the maintenance will be performed, such as time-based or performance-based intervals. And third, the activities that will be performed during maintenance. R1 focuses on the maintenance program, or PSMP as you'll hear referred to today. R2 focuses on performance-based intervals. R3 focuses on time-based intervals and activities. R4 focuses on performance-based activities. And finally, R5 focuses on unresolved maintenance issues. You may have noticed that the time-based intervals and activities are covered in the same requirement, R3, while performance-based intervals and activities are covered in the separate requirements, R2 and R4 respectively. Once we're done speaking to the individual requirements, we'll introduce some references and resources, then we'll open up for questions. Next. This slide looks pretty busy, so please don't attempt to read it. I just want to highlight how PRC-5 has changed from version to version. So before we start diving into the details of the standard, it's important to understand why it exists. This slide shows the purpose statement from all versions of PRC-5, past and present. In the first bullet, the purpose of PRC-5 version 0, and you'll notice that by the dashes at the end of the PRC-5 versions. In version 0, it was to analyze transmission misoperations and to develop and implement maintenance and testing programs. In the second bullet, version 1 removed the verbiage around analyzing misoperations and added verbiage to include generation protection systems maintenance to go along with the already included transmission protection systems maintenance. In the third bullet, version 2 added wording around documenting and implementing the maintenance programs. Moving on to version 3, that's where they added automatic reclosing. And finally, in the last bullet, version 4 added sudden pressure relaying. The purpose statement remained the same in versions 4 through 6. You can see how the purpose of PRC-5 has evolved to end up where we're at today, which is: 1, applicable entities must have a protection system maintenance program, or PSMP. The program must be documented and implemented. And 3, it must include the specific components of automatic reclosing and sudden pressure relaying. Next, please. In the previous slide, we discussed how the purpose statements change from version to version. On this slide, we'll discuss how the materiality of the standard changed from version to version. As we review how PRC-5 has materially changed over the years, it's important to note that some of these versions were never enforceable due to factors such as regulatory orders, timing of those orders, and other standards-related projects. So starting at the top, version 1 basically stated that an entity had to develop a PSMP, and that PSMP had to cover the 5 components of a protection system and the time intervals in which they'd be maintained. As a refresher, the 5 components of a protection system include relays, communication systems, voltage and current sensing devices, DC power supply, and control circuitry. Version 2 added under voltage load shedding, under frequency load shedding, and special protection systems. This version is also where we changed special protection systems to remedial action scheme, or RAS, as they're commonly referred to. In versions 3 through 4 is where automatic reclosing and sudden pressure relaying was added, as noted in our review of the purpose statements. Version 5, it removed dispersed generation from the standard. And finally, version 6, which is a currently enforceable standard, added supervisory controls that are associated with automatic reclosing. Version 6 also combines some of the revisions that were made in versions 3 through 6, which may not have been enforceable depending on your jurisdiction, such as the USA or Canada. That's where we're at today. Next, please. This slide highlights some fun facts regarding PRC-5. The first version of PRC-5 was adopted by NERC in 2005. It became enforceable in June 2007 when mandatory compliance came into effect. After the first year of mandatory compliance, PRC-5 was the most violated standard. Most of those violations were document related. For example, the PSMP did not include all 5 components of a protection system. Version 2 of the standard basically combined and replaced several of the PRC family of standards as shown on the slide. Next, please. Okay, we talked a little bit about where we've been. Let's talk a little bit about where we're going. And this is simply for awareness purposes, just so you know what's coming down the road. PRC-5-6 will be revised under NERC Project 2019-04. And for those of you that aren't aware, every time NERC standards takes on a new endeavor, they call them projects and they're dated as such. So under NERC Project 2019-04, it resulted from a standard authorization request, or SAR, as they're commonly referred to. The SAR requested clarification around the applicability to protective functions within an AVR. Under this project, PRC-5-6 will eventually be replaced by PRC-5-7. Additional areas to be reviewed under this standards project include protection systems within DC excitation systems, non-battery-based energy storage, and electrochemical-based energy storage, as well as prescribed maintenance activities, adding a UFLS-only DP applicability, and updating the PRC-5 supplementary reference and FAQ document, which is available to you today. That all being said, this standard projects have been identified as low priority and is on hold until other higher priority projects are completed. These higher priority projects revolve around inverter-based resources, extreme weather, and BES cyber systems, to name a few. Next, please. Okay, so now we have a Slido question. The overarching purpose of PRC-5 is to, you can read the answers yourself, and we'll give you about 30 seconds or so until we see the responses come in. Mailey, feel free to show the responses whenever you believe we've have critical mass. Thank you.
We'll give it just one more beat, Craig,
Yep.
and then we'll go ahead and get those results up.
Thank you. Okay, excellent. Looks like there's still some responses coming in, but the majority of folks, about over 2/3, picked the correct answer, which is document and implement the protection system maintenance activities. ensure protection systems are designed and implemented correctly. That's not the correct answer because this standard has really nothing to do with designing protection systems and again, providing guidance nor testing automatic reclosing. Those are part of it. The test we didn't provide guidance on methods in the standard. We did talk about the testing and of automatic related pressure relaying equipment, but that is actually not the purpose. So, okay, great job. Thank you. Next, please. Okay, so before we start diving into the details of each requirement, let's do a high-level review of PRC 5-6, just to set the context. Every reliability standard will have these 4 fields at the front of the standard if you're not familiar with them. Okay, so the standard we're going to discuss today is PRC 5-6. The title is Protection System Automatic Reclosing Sun Pressure Relaying Maintenance. And the purpose is, again, to document and implement the programs for the maintenance of all protection systems, automatic reclosing, and sun pressure relaying, affecting the reliability of the BPS so they are kept in working order. And again, this standard applies to transmission owners, generation owners, and distribution providers. Next, please. Okay, over the next few slides, Jessica will be speaking to protection systems, automatic reclosing, and sun pressure relaying, as well as requirement R1. However, before she does this, it's a good time to discuss component and component type because it's important to have a good understanding of these 2 terms as we move forward. A component is an individual, discrete piece of equipment included in a protection system, automatic recloser, or sun pressure relay. A component type is any one of the 5 specific elements of a protection system, any one of the 4 specific elements of automatic reclosing, and any one of the 2 specific elements in sun pressure relaying. We'll be discussing these in more detail in a future slide. Next, please. And now we'll hand it over to Jessica.
Thank you, Craig. So I'm going to go jump in and provide the applicable facilities for PRC 5-6. And this first one is protection systems. So what a protection system is protective relays, associated communication systems, voltage and current sensing devices, station batteries, and DC control circuitry. Applicable protection systems include systems installed for the purpose of detecting a fault on the bulk electric system, also known as the BES, such as lines, buses, transformers, etc. Under frequency load shedding systems installed per NERC requirements, under voltage load shedding systems installed to prevent system voltage collapse or voltage instability for BES reliability. And a protection system as part of the remedial action scheme, also known as RAS, for the BES reliability. Next slide, please. So this is a continuation of the applicable protection systems, but for the generator facilities. So it includes protection systems that trip the generator either directly or via lockout or auxiliary tripping relays. It also includes generator step-up transformers, station service or excitation transformers connected to the generator bus of generators that are part of the BES and act to trip the generator either directly or via lockout or tripping auxiliary relays. Also, aggregated dispersed BES generation from the point where those resources aggregate to greater than 75 MVA to a common point connection of 100 kV and above. Next slide, please. So the next one I'm going to cover is automatic reclosing. An automatic recloser is equipment that automatically adjusts generation in a balancing authority. It can also disconnect a section of a feeder in the event of a fault, such as a short circuit, and make attempts to re-energize a line after a certain period of time. So some applicable automatic reclosing includes supervisory relays that perform voltage or sync check functions that enable or disable operation of the reclosing relay. It also includes voltage sensing devices associated with supervisory relays and control circuitry with the reclosing relay. Next slide, please. And lastly, sudden pressure relaying. So this is a system that trips an interrupting device to isolate the equipment. It's monitoring and includes the following components. So one is a fault pressure relay. This is a mechanical relay or device that detects rapid changes in gas pressure, oil pressure, or oil flow that are indicative of faults within a liquid-filled wired wound equipment. And it's also control circuitry associated with fault pressure relays. Next slide, please. So we're up for our next Slido question. This one's a bit tricky, but it asks, protection systems include all the following except. Okay. So the correct answer is D. It's the last one. So the correct answer is control circuitry associated with a fault pressure relay. So the reason why this is the correct answer is control circuitry associated with the fault pressure relay is actually part of a sudden pressure relay, not exactly protection systems. So we see I only have 23% got that right. Okay, next slide, please. Okay, before I jump into R1, I'm going to briefly cover what a compliance program consists of. So it's important to have a strong program or procedure in place. This program should illustrate what you'll do in accordance with the standard and how you'll do it. So second, you're going to want to implement this program or procedure, and implementation can be examples of maintenance, monitoring, testing, etc. And lastly, you're going to want to track your implementation. So this can be done via maintenance records, inspection records, work orders, etc. You want to make sure that these records are dated and can attest to the implementation your entity is conducting. So remember, if you didn't record it, it didn't happen, technically. Next slide, please. Alrighty. R1 states that each TO, GO, and DP should establish a protection system maintenance program, also known as a PSMP. So this program should include applicable component attributes specified in the maintenance interval tables listed in the standard. Make sure to keep a current updated PSMP as well as any superseded versions from the previous audit. Next slide, please. So creating a PSMP goes back to building a strong compliance program. You should be illustrating what you'll do and how you'll do it, define roles and responsibilities, explain how you'll test your equipment, who will perform the testing, and how often. You want to be sure to track your inventory, maintenance, scheduling, and work completion. And we suggest dated documentation to help track maintenance, as PRC-5 provides maintenance activity interval tables. And I'll cover this in R3. You'll want to archive your data documentation and retain it in accordance with the standard, and keep in mind that your PSMP should be periodically reviewed and updated because procedures may change over time. Next slide, please. Okay, our next Slido question asks, an exceptional compliance program consists of the following except. Yay, good job. So although it does require perseverance to create an exceptional compliance program, creating a program, implementing it, and providing evidence such as the data records that I mentioned is really the foundation of a good compliance program. So good job, everyone. Okay, I'm handing it back off to you, Craig.
Thanks, Jessica. So Jessica's supposed to R1, which requires the establishment of a PSMEP under either the time-based or performance-based maintenance intervals. and the inclusion of all applicable components. R2 only applies to the transmission owner, generator owner, or distribution provider that chooses to establish performance-based maintenance intervals. R2 requires those entities to follow the procedure in PRC-5 Attachment A to establish and maintain justification for the initial and continued use of performance-based intervals. So what are the differences between time-based and performance-based intervals? Time-based intervals are externally prescribed maximum maintenance or testing intervals for components or groups of components. The intervals may have been developed from prior experience or manufacturer's recommendations. The maintenance intervals are fixed and may range from months to years. Performance-based maintenance intervals are established based on analytical or historical results of time-based maintenance failure rates or of similar components. With performance-based maintenance, some level of time-based maintenance is generally followed. Statistical analysis accompanied by adjustments to maintenance intervals are used to justify continued use of performance-based extended intervals when failures occur infrequently. Performance-based maintenance is not commonly used in the Western interconnection. For requirement R2, you can generally expect audit staff to request lists of all segments and components, technical justification for the use of performance-based intervals, while establishing performance-based intervals, documentation that maintenance was performed per the time-based intervals established in the tables in the standard, and evidence of performance analysis, performed analysis, and evidence around the percentages of components, segments, and countable events. Evidence may include artifacts such as component lists, dated maintenance records, and dated analysis records, along with results. It should be noted that the use of performance-based intervals is not common in the Western interconnection. Okay, next, please. Okay, let's discuss what a countable event is. A countable event is a failure of a component requiring repair or replacement. Any condition discovered during the maintenance which requires corrective action or a protection system misoperation that's attributed to hardware or calibration failure. Misoperation is due to product design, software errors, relay settings, that are set from different specifications, or configuration or application errors are excluded. Next, please. Okay, this slide shows the tables in attachment A that are used to establish and maintain the justification for the initial and continued use of time or performance-based intervals. These tables are referenced in R2 regarding performance-based intervals, which we just discussed. And they're also referenced in R3 recording time-based intervals that Jessica will discuss in a moment. We'll review one of these tables simply for familiarization purposes. The top row of the table in dark blue displays the table number and the title for which components this table is established for. The second row in lighter blue displays the column headers for the component attribute, the maximum maintenance intervals, and the maintenance activities. Under each column lies the relevant details. Let's walk through this one time. The first row in the first column indicates the component attribute to be any fault pressure relay. This is referring to the relay itself and not any other component attributes such as control circuitry. Moving to the right, you'll notice that 6 calendar years is the maximum maintenance interval allowed. And moving to the right yet again, you'll notice the maintenance activity is to verify pressure or flow sensing mechanism is operable. Again, this was just to give you a basic feel for how the tables within the standard are arranged. Next slide, please. Okay, our next slide of question is requirement 2 covers time-based maintenance in accordance with the minimum maintenance activities and maximum maintenance interval prescribed within PRC-5-6. True or false? Okay, it looks like we got a little bit of an even split here. Really, the correct answer is false because requirement 2 talks about performance-based maintenance as opposed to time-based. So, okay, that was sort of a trick question. I apologize. Okay, at this point, let's hand it over to Jessica to cover the R3.
Thank you. Okay, so rolling into R3, R3 utilizes time-based maintenance. Time-based maintenance is most commonly used amongst most entities, and this maintenance is implemented in line with the interval tables described within the standard. So artifacts include, but aren't limited to, dated maintenance records, maintenance summaries, checkoff lists, inspection records, or work orders. So make sure to keep the documentation of the most recent and prior performance of the maintenance activity that you guys perform. Next slide, please. So this is a protection system maintenance summary spreadsheet. This spreadsheet is used to keep track of all applicable components for your entity and ties into R3. This is an Excel sheet that has several tabs at the bottom, starting with the instructions. It provides options for stations and components such as transmission or generator devices, UFLS, UVLS, and RAS. Next slide, please. Let's talk about tab number 2, implementation dates. So these implementation dates and percentages differ between US and British Columbia entities. These are enforceable dates for components and the percentages required to be compliant. So for example, 100% of all sudden pressure components that have a maintenance interval of 12 calendar years, and again, this is based off the tables in the standard, need to be tested by 1/1/2029 for US entities and 10/1/2031 for British Columbia entities. So it's important to note that these dates are mandatory and it's not a suggested date. All components must be tested to be compliant. Next slide, please. So we're moving on to tab 3. In this section, you'll provide a list of all BESS transmission substations, generating stations, and distribution stations that include components applicable to load shed. So in this example, the table up at the top, under station name, Old MacDonald had a farm. So he listed his farm, his substation, and his mills. Next slide, please. So this is covering tab 4, and it's really getting into the meat and potatoes of the spreadsheet. In here, you'll need to fill out a couple of fields. So if you look at the first table to the upper right corner, the first column is the station name, and this is where Old MacDonald would list any substation, mills, etc. So the next column is the component name. This is a unique identifier that will help auditors like myself pinpoint the component and maintenance documentation, such as your testing records. Sometimes we don't see this field, sometimes we see this field blank, and it's important to note that if we don't have a unique identifier, the documentation you provide is unusable. So we compare the testing results to the component name, and this assures us that the maintenance is being done and the component on the spreadsheet that you provided is accounted for. The next column is component description. So for example, we have on here SEL 421. Following the component description is the component table, and this is where you'll list applicable tables for each device. So for example, on one of the lines, we have component name 7212. This is a protective relay, and it falls under the maintenance table 1-1. So on the next column is component application, and this is where you'll list your components if they're UFLS, UVLS, or RAS. And lastly, if you take a look at the table lower to the left-hand corner, you'll see the columns for test dates, program version used, maintenance intervals, and general notes. So the last and prior test dates are pretty much self-explanatory. This is the dates that you'll put of your equipment when it was tested or maintained. And keep in mind, if you have a new installation or a replacement, you can put this in the notes, and the date you provide can be the date that the equipment was replaced or installed. The maintenance interval, the maximum maintenance interval column should have the interval provided in the standard, while the selected maintenance interval should be what the entity selected. So this interval can be equal to or less than the maximum maintenance listed in the standard. And then the last column is general notes. This can be used for energization dates, component ownership, if you did a replacement, and it can also be left blank if you don't have any comments to make. Next slide, please. Okay, so we're just going to do a recap. What we're looking for is completeness, no empty fields in the spreadsheet. So please make sure that the prior and last test dates are filled, and the time between each test should fall within the applicable intervals listed in the activity tables. And like I said, you can also use a commissioning date as a test date. And to reiterate, the component name is a unique identifier that will help in reviewing test records and matching them to the component listed in the spreadsheet that you all provided. And the general notes can be used for energization dates, component ownerships, replacements, and can be left blank as well. This should be the only field that could be left blank. And your selected maintenance interval is what you set as an entity, and it must be equal to or less than the maximum maintenance intervals listed in the standard. Next slide, please. So here's some implementation recommendations regarding R3. What we look for is consistency. Is your maintenance program in line with your PSMP? Are you doing what you say you're doing? So are you testing how your program described? Ensure that your contractors are following your PSMP as well. Applicable components are being tested in accordance with the activity tables listed, and the correct tables are being used for the correct components. And then we also want to see if you're meeting your intervals, which goes back to the tab 2 of the spreadsheet. And if you are, you need to be at the percentage that's provided by the date to be compliant. And then we want to make sure that your maintenance records are consistent and accurate. So lead us to the answer. So a lot of the times when evidence is provided, we get a lot of paperwork and it's a lot to look through. So it'd be really helpful if you can circle or highlight test results. So for example, inputs and outputs, you can highlight that in your testing information, and it's super helpful when we have a lot of documentation to review. And lastly, no fluff. More isn't always better. Adding information or documents that aren't required isn't necessary. It just creates information overload. So like I said, what we ask for, just provide what we ask for. Next slide, please. Okay, this next slide is a Slido question. The component unique identifier in protection system maintenance spreadsheet is labeled as which of the following? Awesome, 64% component name. Yes, 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 yes. Okay, thank you all. I'm gonna hand it back to Craig.
Okay, thank you, Jessica. I previously spoke to R2 regarding establishing a performance-based maintenance program. R4 goes along with R2 in that R4 requires implementing and following the performance-based program that was established in R2. For transmission owners, generator owners, and distribution providers that choose to use performance-based intervals, you can generally expect audit staff to assess the following. Did you establish or maintain protection system, automatic reclosing, and sudden pressure relaying components in segments that in accordance with the performance-based maintenance intervals that are in effect during the audit period? We haven't discussed the segments yet, so segments are simply components of a consistent design standard or a particular model or type from a single manufacturer that typically share other common elements. Consistent performance is expected across the entire population of a segment. A segment must contain at least 60 individual components. And there's a lot more information available as to segments. Additionally, audit staff will try to assess where the monitoring is used to determine component maintenance activities. Did you maintain the alarm paths associated with the protection systems, automatic reclosing, and sudden pressure relay components? Did you ensure supporting documentation for the performance-based maintenance activities performed during the audit period on components was completed. Did you plan for transitioning maintenance from previous versions of PRC-5 to PRC-5-6 in accordance with the PRC-5-6 implementation plan? If you're not aware, there is a PRC-5 implementation plan out there that talks about how the phases of each component and section will be implemented. It includes dates. As part of that transition plan, did you ensure that the percentages maintained during the transition to PRC-5-6 are in accordance with the PRC-5-6 implementation plan? Next slide, please. Okay, one thing we haven't discussed yet is evidence retention. You should give some thought to how and for how long you'll retain your evidence of compliance for all the standards you're subject to. Most reliability standards address evidence retention, so that's a good place to start. This slide specifically speaks to R4 and the retention of evidence of implementing your performance-based maintenance program. Regarding R4, you should consider the following. In cases where the maintenance interval is longer than the audit period, you should retain documentation of the most recent performance of the maintenance activity. In cases where the maintenance interval is shorter than the audit cycle, you should retain all documentation of all performance of maintenance activity since the previous audit date. Once again, let's hand this back over to Jessica, who will now speak to R5.
Thank you for leading us into R5. So R5 is unresolved maintenance. An unresolved maintenance issue is a deficiency identified during a maintenance activity that causes a component not to meet the intended performance. It cannot be corrected during the maintenance interval, and it requires a follow-up corrective action. Next slide, please. So R5 implementation consists of demonstrating an effort to correct identified unresolved maintenance. So this can be exemplified in work orders, replacement component orders, invoices, project schedules, return material authorizations, etc. So you want to keep the documentation of the unresolved maintenance issues since the last audit, including all that were resolved. Next slide, please. So in R5, the standard is looking for an effort to correct. Some implementation recommendations are putting the priority of the maintenance and procedure to resolve the unresolved maintenance in your PSMP. So for example, what will you do if you cannot correct it in a timely manner? You want to give yourself a time frame to correct and identify issues and follow through. And lastly, you want to track. Tracking of your unresolved maintenance via spreadsheet workflow is a great way to demonstrate your efforts and to keep in line with your designated time frame that you set in your PSMP. Next slide, please. So this is our last slide of question. Yay! Unresolved maintenance issues evidence can include the following except. I hope I see 100% for the answer on this slide. Okay, delivery receipt, that is not the correct answer. I'm just kidding. Good job, everyone. Okay, I'm going to hand it off to Craig to close out our presentation.
Okay, thank you, Jessica. So if you'd like more information on PRC-5, here's some links to additional resources and reference. It contains a lot of good information. If you receive a copy of the PowerPoint presentation, these are actually working links. So now we'll open it up to questions.
Hi, Craig. I just want to share with the audience that we have not yet posted the presentations, but we will when we get the recordings up, that those presentation decks will come with it. We did get a question about the Protection Systems Maintenance Summary spreadsheet you shared on around slide 41. Is there a copy of that spreadsheet available?
Yes, I believe so. We have it on the WECC website. Maybe I can add that to our resources. That
That
way
would be
you
great.
can refer to it.
Yeah, great. We'll make sure that link is available. It sounds like there is one.